In this video, I start to take care of the register control circuitry. This is going to include getting the line drivers installed, getting the LEDs working, and starting the extension of the control lines to all the different integrated circuits.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay. I have this LED graph that I want to use to indicate all the different controls that are happening on the register. This one's got 10 LEDs on it. This one is all red. These are all 10 red LEDs on here. And I believe the cathode and anode are switched opposite of the others. I'm going to drop that right in there. So that'll give me the ability to show 10 different controls. And then to do that, I want to actually separate the LED output from the actual signals, and I'm going to do that by line drivers here. And for the line drivers, I'm going to add power and ground. Unfortunately, the ground is going to be difficult to get to for this IC on the right. Let me see if I've got something long enough in here. I probably do not. Let's see here. If I can go from here to there, that would work. Okay, that works. And then power up here. Let's try that with one wire. Okay, power and power. And then, so that gives me the ability to display 10 signals, but buffer 16 signals. And switching over, I have actually collected a list of all the different controls that I need to output. And I actually have 11. One more than I have LEDs. The clear signal is not going to be the signal that I'm going to display. It's just a design decision. I could have added an extra LED in there in order to do that. And I may yet do something like that, but not quite yet. I'll probably end up adding it on the final build once I convert it to printed circuit. So I'm going to have a load counter signal, which is an asynchronous low signal, an increment, which is a rising edge. I'm going to set that to be normally high, and then the indicator is going to go on when low, and then when it goes off is when it's going to increment. The decrement's going to be the same. It's a rising edge. Normally, I'm going to have that signal high, and then when the signal goes low, when it returns back to high, is when it's going to decrement. Again, the LED will be on during the low signal. The latch indicator is a rising edge. It's normally high. I'm going to have, again, low right before it's going to be latched. The other ones are active low signals, which are relatively easy to deal with. The thing here is the only signal that is different is the clear counter signal, which is a active high signal. Everything else is active low. So for this LED graph, I need to connect power up here to the power rail. And then for each of these lines, they're going to be pulled, and whenever the signal is low, it's going to have to sync some current coming out of these LEDs. So I want to use some relatively high value resistors up here in order to prevent the LEDs from getting too much or too bright, and B, make sure that the ICs don't have to sink too much power. So I'm going to use 1K resistors up there. And I've got several of them I can put into place real quick. So let me get those. I've also been thinking a little bit about the length of the videos that I've been producing. They're a little bit longer than I had intended. And so I am going to shorten this one a little bit with the hopes of keeping it a more reasonable length and a more aggressive release schedule so that I'm not editing up hours and hours of video to try to fit it into a reasonable amount of time. Rather, I'll take smaller chunks of work to do and produce shorter videos more frequently. What I ended up having to do was, because of the way things were lining up, I had to add an extra resistor off the end here and just stretch it over to one of the LEDs that was missing one. And then if I look at these, they all light up. I have some kind of a large resistor here, larger than I was anticipating. I'm not quite sure what size that LED was, but it wasn't the right size. So I'm going to pull off another, or not LED, I said LED, I meant resistor. So I'm going to pull another resistor off here, cut it properly, and drop that in here. And that's plenty bright. I want to think, I believe that was a 1 million ohm resistor. So even the LED here that is stretched across, it all has the same brightness here. So for the 74 LS541, both pin 1 and pin 9 are control signals which need to be pulled low. So let's get those wired up here on the ICs. Pin 1 is low. And pin 1 is low. And pin 19, now this is going to be a bit of a challenge. Might have to cut some wires for those, but in the meantime I will save those for the cleanup and do pin 19 low and pin 19 low. So now I'm outputting. Getting into my hookup wires here. I think I'll try to use green. It's almost like trying to sort through M&Ms and organize them by color. So then if I take pin 11 and tie it up to the first signal, now it doesn't matter which pins I use on which for which signal. I've got 8 on one and I've got 2 on another IC, that is integrated circuit. And then so that then should give me the ability to, when any of these go low, the indicator goes on, meaning that I've actually got some kind of a control logic here that's going to be handled. But if all of these are low, this integrated circuit here is going to have to, and that shouldn't be the case. I'm thinking about this. Hang on a second. Let me run back here. Looking at this, I'm seeing there are 6 theoretically potential signals that could be low at the same time. That's a theoretical maximum, and those would be the asserts to the different buses. And while that is technically possible, that's not necessarily what we're going to allow in programming. Address bus 1 and address bus 2 technically could be used at the same time, but not likely. ALU A and B absolutely could, along with a main bus, but that's probably not going to happen very often. So I think we're in good shape here, is my point. What I believe we might be able to do to make this just distributed a little bit better is take 3 signals off of this and move those up to this IC. By evenly distributing the load between these two ICs, we're not overworking one, having to sink too much current at any given time. Let me get that wired up, and then I'll come back and we'll talk about actually extending the signals off to the different chips. Now, I have said that anything that's unused needs to be tied one direction or the other, not leaving things floating. So with 3 open unused pins on this IC, I'm going to tie them all low. And this is again because I'm going to be using CMOS on the actual breadboards, not the, and I'm probably going to pronounce this wrong, Schottky or LS ICs on that I'm using here on the breadboards. So let me restate that because I think I said it wrong. I'm not going to be using the LS ICs on the printed circuit. I'm going to be using CMOS ICs on the printed circuit. So anything that is unused needs to be definitively tied one direction or the other. And so the 3 unused pins on the upper portion of this 571 and 3 upper pins on the unused portion of this 571. Remember, pin 1 is the control signal. These 3 pins are unused, are going to be tied low. So now if I take a hookup wire and I go along each one of these that is not, they should in turn all light up, meaning that I can then use those to indicate my signals. Now, these 541s up here, I currently have the orange wires jumped from one side to the other, from pin 1 to pin 19, so that they're tied together for my testing. Pin 1 can all be tied low, or pin 19 can all be tied low. And then the alternate other signal could be used to then drive the signal. I'm going to tie the lower one, pin 1 low, on each of these. And the reason I'm going to use pin 1, is it's harder to get to wire up. Okay, so now that cleans up these control lines a little bit. Now I need to extend these down so that they're hooked up to the inputs to each of these line drivers. And I think I'm going to take the outputs of every one of these except for this one off of this line driver, and this one, since it is the byte swap one, I'm going to move up here with these other LEDs or these other line drivers. So let's see how we can do this. I have some longer hookup wires here. This signal here will come down to here, where I'm going to tie this low. So the next one in line here is ALUA. Next one is this, which is ALUB. And so that's going to be address 1. Final one here is address bus 2. Having taken care of all the address asserts, I've got the load, increment, decrement, and latch. Right now I've got the increment tied to the clock here. That's going to be this signal here. So load increment, and we will tie that signal low, and then when we bring it back high, low to increment, bring it back high. The parallel load is down here, which is tied high at the moment. I'm out of long yellow wires, so I will switch. Oh no, I have one more. So parallel load is on that signal there, which would go to there. And I'm going to use orange over, or I still have a couple yellows over here. So parallel load, if that goes high, if I clock, it didn't have anything to load. We'll test that. The clear is a high signal. And just for convenience, I'm going to bring the clear over to just an empty spot over here. Increment, decrement, and then the latch. Now the latch right now is happening on the clock as well. And what I want to be able to do is change that out so that the latch happens on this signal. So these are out of order. And then the decrement is here, whereby the decrement should be that signal there. And then if I take the yellow wire and tie that low, I get a signal. And if I tie it high, that should work. So now all of these lines need to be replaced with yellow wires and routed all over this board. Now, the challenge with the yellow wires routing all over the board is going to be literally how to route them. The ones up here and literally we're probably going to just come down the side of the board here. Before I get into that, let me grab a couple of decoupling capacitors for the two new ICs that I put on. Get those bent up and then shorten these leads a little bit. Again, between the power and ground pins directly. And let's cut this one to be the same size. Okay, and then I'll work on getting these yellow lines wired up. The ones down here I'm going to keep for now until we get everything hooked into the control module itself. So these wires down here, these wires down here, I'm going to just leave there for now as my control. So remaining, I have to complete the register control circuitry, and then I do want to move this into KiCad immediately so that all of the ICs, all of my connections and everything can be traced readily. I still have a few things to do with the clock, which include troubleshooting the single step bounces. And then I want to get into defining the assembly and opcodes quickly. This is something that I want to handle sooner rather than later, because it's going to give us a frame of reference as we continue to build out the control module. Thanks, and we'll see you next time.